So now let's take a look at how we can get this texture to fill up the screen and repeat. We'll change the quad's name to background. And now let's take a look at its transform. Our scale is set to 32 by 32. If we were to make this 10 times larger by multiplying it by 10, we would have 320 by 320. Now we'll zoom out a little bit, and what you'll see is that instead of this repeating, it actually just grew larger. In order for this to actually work, we need to go to the material itself and change the tiling value. Here, we need to set this to 10 by 10. Now you'll see our textures repeating. But of course, we can't do this all the time for every single screen resolution. We're going to need to create a script that takes the resolution into account and then automatically sizes up our quad and changes the tiling value on the material. So let's reset this all back. We'll make sure that the tiling is 1, and back in our game, we'll reset the background to 32 by 32. Let's go into our scripts folder and create a new script called tiled background. Then we'll open it up in MonoDevelop. Now in this script, when it starts up, what we're going to do is take the size of the tile that it currently is, which is 32 by 32, and we're going to try to figure out how many tiles fit within the current screen width and the current screen height. Then we'll take that value and we'll change the material's texture to also match that so that we see them cleanly repeating across the background. To get started, let's set up a public property that'll represent the native texture size. Now, one thing to note is that this is going to only work in powers of 2s. So this kind of script will work best with textures that are 16, 32, 64, 128, etc. moving up. So if you did change the background to your own texture, try to keep it within this power of 2. Next, in our start method, we're going to have to do some math. Here we're going to have to calculate a new width and a new height. First, let's create a variable for the new width. Because we're trying to calculate how many tiles will fit inside of the screen's resolution, we definitely don't want it to be smaller than the screen's resolution. So if we were to round this down, we'd wind up with possible gaps on either side of the screen. So in this case, we're going to use a math function called ceil, which will round things up to the highest value. Unity has its own math class called mathf. And in order to access ceil, you simply type in ceil. Next, we're going to need to get the screen's width. From there, we're going to want to divide it by the texture size multiplied by the pixel perfect camera's scale. And then we're going to close this equation. Now, we've already calculated this scale, and it's important to note that we're not doing this in the awake method. If we were to do this in the awake method, we could run into the possibility that the camera hasn't set itself up yet. So from now on, whenever we need to access values of the camera's scale, we're going to do this in start to make sure that everything is set up correctly. Now let's copy this line of code, and we're going to paste it below and change it to height. Here, we'll make it the new height. We'll use the screen's height, and we'll leave texture multiplied by pixel perfect scale the same because we know our texture is 32 by 32. Now we want to change the scale of the quad based on this new width and height. In order to do that, we're going to access a property called transform local scale. And then we're going to create a new vector 3. Now, this is a little confusing when working in Unity, because sometimes, as you'll see later on, we'll be using vector 2s, which are just x and y, and sometimes we'll be using vector 3s. Because at Unity's core, it's still a 3D engine, things like scale and position all require vector 3s. And it's incredibly important to make sure that we always use a vector 3 for local scale, because if we were to set the z value of local scale to 0, the image would disappear. Now, we can take our calculated new width and use this for the x value, and we're also going to have to remultiply it by the texture size. This will give us the correct scale to use horizontally. And now we can do the same thing for the height. We'll use new height multiplied by texture size, and then finally we'll use a value of 1 for the scale's z-axis. Once we've set the scale, now we need to tell the material that we created that it has a new texture scale. In this case, we're simply going to call getComponent. Here, we're going to access the renderer. This is what actually displays the material in the quad. We'll get a reference to the material itself. And then from here, we can change the main texture scale. In this case, we're going to create a new vector 3. Now, we don't need to calculate the full size. All we need is the new width that we calculated in the new height. So let's supply those. New width will go into X, new height will go into Y, and we'll use 1 as the Z value. At this point, our code is done. In fact, we can delete the update method because we don't need it. We'll save our script, and let's go back into Unity. Now let's add the tiled background onto our background game object. And when we run the game, you'll see that the texture now scales itself correctly according to the camera. If we select the camera and zoom in, you'll see that the texture actually moves a little further out from where the camera is. Now, two things are happening. One, our background isn't set to a proper 0, 0 position, so let's fix that. But even when we run it again, you'll see because we're using Math Seal, we're actually getting the overage we need to make sure that we never see empty space on the sides of our game. At this point, our texture is complete, and we now have a repeating background.